I'm Anil Kumar. Welcome to my videos on quadratic relations. Here is an excellent example. We'll actually have 3 questions based on this situation. The situation here is, a store sells aromatic candles for $4. At this price, the store sells approximately 20 candles a day. The store owner decides to raise the price of the candles, knowing that each price increase by $1 will result in 2 less candles sold. The quadratic relation R equals to minus 2x square plus 12x plus 80 models the situation where R is the revenue or sales in dollars for candle sales and X is the price increase in dollars. Now, based on this situation, you have 3 questions, all multiple choice. The first one here is, what should be the price of each candle in dollars to maximize revenue? You can actually pause the video, answer this question. Now, second question, which is based on the same situation, is how many candles will be sold in a day to maximize revenue? 4 options are given to you. And the third question here is, what is the maximum revenue for candle sale, right? So given 4 different options. So I'd like you to pause the video, answer this question, and then look into my suggestions. Now we could have different kinds of approaches to solve this particular question. Let's begin from part 3, right? So let us see how to answer this question. All are related. Now remember, the original cost is $4 and the store is able to sell 20, right? So the revenue here you can see is 4 times 20. This is $80. This is without change in price. Now what we're given here is that for every increase in $1, there will be 2 less candles sold, right? The quadratic relation for revenue, where X is change in price, is given to you. Now revenue, you could actually maximize from here itself. So let's work on this equation R equal to minus 2x square plus 12x plus 80. So we can maximize. So we'll do completing the squares, taking minus 2 common first. We get x squared minus 6x plus 80. And now we can do half of 6. So minus 2, x squared minus 6x, half of 6 is 3. So we'll add and subtract 3 square. Add and subtract 3 square plus 8, correct? So that gives you minus 2. Here in the bracket, you have x minus 3 whole square. And when you multiply minus 2 by minus 3 square, which is 9 times 2 is 18, right? You get plus 9 times 2. This is 80, I'm sorry. 9 times 2 is 18. You get plus because minus and minus makes it plus 80 gives you this part, which is the maximum revenue, right? So let me rewrite this as here. We have revenue equals to minus 2 x minus 3 whole square plus 98. So the maximum revenue is 98. So one way is that you could actually do completing the squares and find your answer. The alternate method in this particular situation is that in any equation of the form y equals to ax squared plus bx plus c, maximum occurs at which value? You can see from here at x equals to minus b by 2a, x equals to minus b by 2a. So that is a standard formula, right, which you also get from completing the squares. So here you could have got this value direct as x equals to minus b, which is minus 12, divided by twice a, which is minus 4. And this value is 3, right? So 3 is the change in price, which will give you maximum revenue. So that is one way you could do. But completing the squares helps, especially when you have 3 questions to answer. So you have also found from here that the change in prices is 3. That means for original price of 4, $7 should be charged for getting a maximum of 98. Does make sense to you? So I think we have answered all the questions because of doing one particular calculation. So let me take the very first one now. So back to first one. Now if I would have started with this question, working with r equals to this, we found that we could have got this revenue as equals to 2 times x minus 3 whole square plus 98, right? So here this 3 is change in price. Remember that part. This is change in price of 3. That means we are increasing by 3, right? So the cost is actually 4 plus 3, which is $7. So option is A. So do not mark 3, right? We want the final price, correct? Now, one could also solve this question without really completing the squares. I will show you that part also in our next slide. Well, let's look into this now. So we'll actually adopt different methods to solve this. So in a multiple choice test, you could actually use one of these. Here, how many candles will be sold in a day to maximize revenue? Right? So now we'll see how many candles to be sold. Well, we have understood one thing, that if the original price is $4, right? And for every increase in price, which is x in our case, from 20, we actually decrease twice this number increase, right? So this is the way of looking into this situation without looking into this. Actually, revenue equation given to us makes things very difficult. Now what we have found in previous examples, that the value of x is equal to 3. So this is the number of items sold. This is numbers, right? So this part is the numbers and this is dollars, correct? So the numbers will be 20 minus 2 times 3, which is 20 minus 6, and that gives you 14, correct? So option C is the correct option. Now try to get this answer 14 using the given equation. It is very difficult. You are getting my point, right? It is very difficult. So if that is the only question asked, in that case, my suggestion will be you could form your own equation and then do it. Or what you could do here is that make a table. For $4, let me show it here. For $4, you are selling 20 candles, right? So that gives you $80 as revenue. Now when you increase the price to 5, you're able to sell 2 less, right? So it is 18 here, correct? So when you increase the price, you are selling lesser number of candles, right? Now if 18 is not the option here, so we'll just forget about it. If you go for 6, then it will be 16. Then you can just try multiplying these numbers and see whether you get more revenue or less. 6 times 6 is 36, and 6 we get 96, more revenue, right? Now if I increase this price by $1 more, then we are going to sell 14. Now if I multiply 7 with 4, I get 28, and I get 98 as my answer. Now 98 is higher than the other ones. Let's try for 8 also. 8 times 12. 12 times this is 96. So the highest value is only for C. So without doing all those calculations, which we did, we could actually work in this fashion for such questions. I hope you understand it. So if you have a question like this in a competitive exam, multiple choice, you could adopt this particular method of increasing and decreasing and just multiplying and getting your answer. At times, this question could be under calculator head. So you could calculate it even faster than what I did. So I hope that helps. Feel free to write your comments and share your views. If you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.